We want to decompose this rational expression into partial fractions. To begin, you want to factor the denominator. This denominator factors into x plus 4 times the quantity x plus 2. So the number of factors here tells us how many partial fractions we're going to have. So we'll have two partial fractions, the first with the denominator of x plus 4 and the second with the denominator of x plus 2. And we're solving for the numerators. So our first numerator is an unknown constant, I'll call capital A, and my second numerator is an unknown constant, I'll call capital B. So we proceed as if we're just adding the fractions on the right-hand side. So we need a common denominator. Our common denominator is going to be x plus 4 times the quantity x plus 2. So we need to multiply the first fraction by x plus 2 divided by x plus 2. And the second fraction we need to multiply by x plus 4 divided by x plus 4. So this will give us a times the quantity x plus 2 plus b times the quantity x plus 4. Distributing leaves ax plus 2a plus bx plus 4b, all divided by x plus 4 times x plus 2. So this is equal to what we started with, 2x plus 2 divided by x squared plus 6x plus 8. But I'm going to go ahead and write this denominator in its factored form, because I want you to see here that the denominators are the same. So if the denominators are the same, then the numerators must be equal. Or, let me state that a different way. If you were solving this equation, you would want to multiply both sides by the denominator, x plus 4 times x plus 2, to eliminate that division. And what we do to the right-hand side of the equation, we must also do to the left. So if I multiply the left side of the equation by x plus 4 times x plus 2, it would also then eliminate the denominator, leaving us with just the numerators. 2x plus 2 must equal the right-hand side. And I'm going to reorder what I have on the right-hand side. You'll notice that on the left-hand side, we have the x term written first. So let's go ahead and write the x terms first. So that would be ax plus bx. And then what's remaining is the positive 2a plus 4b. All right, so on the left-hand side, we have the term 2x. So 2 is the coefficient of x. On the right-hand side, we want to determine what the coefficient of x is. So we need to factor the first two terms. So factoring the right-hand side, we can factor out an x. We'll be left with the quantity a plus b. So on the left side, the coefficient of x is 2. On the right side, the coefficient of x is the quantity a plus b. So that's going to give us the equation a plus b equals 2. With that same line of thinking, on the left side, the constant in the problem is a positive 2. On the right side, the constants are 2a plus 4b. And that'll give us the second equation, 2a plus 4b is equal to 2. So now what I have here is a system of equations. It's a two-variable system of equations. And now perhaps you can see why we'd be studying this topic right now, since we just finished studying systems of equations and the different methods of solving. This is one application of systems of equations. So now we have a system that we need to solve. A plus b is equal to 2, and 2a plus 4b equals 2. So we can solve using substitution or elimination. This system is set up nicely for substitution. So if we're going to eliminate the a variable, then we would need to multiply the top equation, the left and the right, both by -2. This gives us a new equation of -2a minus 2b is equal to -4. And my second equation was still 2a plus 4b equals 2. But now when I do my elimination, I'm adding these two equations together. I see that -2a plus 2a becomes 0. So I'm eliminating the variable a. And I end up with 2b equals -2. So b is equal to -1. Substituting this back into one of the original two equations will let us solve for a. I'll choose the simpler of the two. The first one is a plus b equals 2. So if b is -1, that gives a minus 1 equals 2. Therefore, a is equal to 3. So going back to the original problem so we can write our partial fractions, you'll remember that the original problem we set up here as the two partial fractions, a divided by x plus 4. So our a value we got was 3, so that would be 3 divided by x plus 4. And our second partial fraction was plus b divided by x plus 2. So plus our b value is -1 divided by x plus 2. So you could leave your partial fractions in this form, 3 divided by x plus 4 plus -1 divided by x plus 2. Or you could also write that as 3 divided by x plus 4 minus 1 divided by x plus 2 if you wanted to write it as a subtraction problem. Either of these two answers would be acceptable. So these are the two partial fractions, and if you had gotten a common denominator and added these fractions together, you would end up with what we started with, which was the 2x plus 2 divided by x squared plus 6x plus 8.